This video is going to start our discussion on reaction types, and chemical reactions can be divided into 5 types. The first is synthesis, the second is decomposition, the third is single replacement, the fourth is double replacement, and the fifth is combustion. There is one variation, and that's called a thermochemical, and that applies to all 5 types, and there are 2 subtypes. The first is acid-base reactions, which some people call a 6th type of reaction, but really it's a subtype of double replacement, and then reduction, oxidation, or redox reactions, and that's a subtype of several of the other 5. Let's start with a synthesis reaction. In a synthesis reaction, many reactants become one product, and by many I mean more than one. Generically, A plus B becomes AB. Classic example, the combination of hydrogen gas and oxygen gas to make water. That's a synthesis reaction. Well, if you can make things, you can break things down. So a decomposition reaction is when one reactant becomes many products. Or CD breaks down to form compound C and compound D. In real life, solid calcium carbonate, chalk, when heated up, will form solid calcium oxide and carbon dioxide gas. One becomes many. In a single replacement reaction, one element knocks out and replaces another in an ionic compound. Classically, a metal replaces a metal, or a nonmetal replaces a nonmetal. Generically, E plus compound Fg, everything rearranges and you now have element F and compound Eg. So chlorine gas, when mixed with aqueous potassium bromide, will react and you will get liquid bromine and potassium chloride. The chlorine has bumped out the bromine. In a double replacement reaction, 2 ionic compounds switch ions with each other, becoming 2 new ionic compounds. Here is the generic form, HI and JK, and the H and the J swap positions, the cations, and you get HK plus Ji. Here, calcium chloride, which is aqueous, and sodium carbonate, which is aqueous, becomes calcium carbonate, which is a solid, and sodium chloride, which will be aqueous. When you have a double replacement reaction, you must have at least one of the following products be in the following state. A solid, which is scientifically known as a precipitate, a liquid, which is usually water, and a gas. You can have more than one of these, but you must have at least one in a double replacement reaction. A combustion reaction, we have a very specific definition. It's when a hydrocarbon, compound made only of carbon and hydrogen, or a carbohydrate, which contains carbon, hydrogen, and oxygen, reacts with oxygen to produce both carbon dioxide and water. There is really no generic equation. Here, propane combusts with oxygen to form carbon dioxide and water. Propane is a hydrocarbon. Here, C2H6O plus oxygen forms carbon dioxide and water. Now, a key point is you must have molecular oxygen on the reactant side in order for this to be a combustion reaction. It will only produce carbon dioxide and water. If there's no oxygen on the reactant side, it is not a combustion reaction. Now, all chemical processes involve a change in energy or heat. For example, a cold pack you can buy from the drugstore is actually a container of solid ammonium nitrate and a plastic bag of water. When you pop it, the water bag breaks, the ammonium nitrate dissolves and becomes ammonium ion and nitrate ion. That dissolution of the ammonium nitrate causes the water temperature to drop. On the other hand, propane, which we saw in a previous example, when it combusts, releases heat. So now we need some definitions. Systems. The system is what we are looking at. That is usually the chemicals. The surroundings is everything else, not the system. So we tend to just look at things very close to the system. Heat is energy transfer between system and surroundings, and it has the abbreviation delta H. We can't measure the actual heat, we can only measure the change in the heat. Enthalpy is just a fancy term for heat. Same symbol, delta H. So you'll hear people talk about heat, and talk about enthalpy interchangeably. They are synonymous. Enthalpy is the more scientific sounding term. Endothermic is when heat goes from the surroundings into the system. In an endothermic process, the delta H is positive. In an exothermic process, heat travels from the systems to the surroundings, and delta H is negative. So ethanol, C2H6O, will combust in the presence of oxygen to produce carbon dioxide, water, and heat. Now you can write out the complete molecular equation, but you may be asked to write out the thermochemical equation, or you may be given the thermochemical equation, and that looks like this. So let's take a look at this equation and things you're going to note. First, the coefficients do not have to be whole numbers, but they have to make sense. You can have half of an O2 because the O2 can become O plus O. You could not have a half of an ethanol because you can't split that compound in half. Delta H, the units are kilojoules per mole of reaction. Delta H is an extensive property then. The more moles, the higher the kilojoules. Delta H value is stoichiometric. Notice the per mole of reaction. You can do stoichiometry calculations with the delta H. So for example, if you double the amount of ethanol being combusted, you will double the heat production. If you quarter the amount of ethanol, the heat production will be quartered. So let's just jump into an example. 6.91 grams of dimethyl ether, which happens to be an isomer of ethanol, when it's totally combusted, produces how much heat if the delta H for dimethyl ether is minus 1,460 kilojoules per mole of reaction. We're going to follow the steps because delta H is a stoichiometric value. So we start out by writing the correct balanced equation. Here we have to include the delta H. Identify the if or then. Well, if we have 6.91 grams of dimethyl ether, so the dimethyl ether, C2H6O, is the if. How much heat will be produced is the then, so delta H equals minus 1460 kilojoules per mole of reaction is the then. Convert grams to moles because we're not in moles, and stoichiometry is mole ratio. 6.91 grams divided by the molecular weight. And so we have 0.150 moles of dimethyl ether. We don't know what the value is for delta H. Now we're going to set up the ratio. So minus 1,460 kilojoules per mole of reaction is to 1 dimethyl ether as X is to 0.150. Now we're going to solve the sucker. So you cross multiply and divide, and you get a delta H of minus 219 kilojoules. If the delta H is negative, this makes it an exothermic reaction. It gives off heat. So here's one for you guys to try. We're going to let gaseous hydrogen react with gaseous oxygen, and water will be produced. The heat of formation, or the delta H, for gaseous water is minus 242 kilojoules per mole of hydrogen. We're going to allow 8 grams of oxygen to react with an excess of hydrogen. So how much heat should be released? Stop, figure it out. I'll give you the answer, then walk you through it. Go. And the answer is minus 121 kilojoules of heat should be released. This is exothermic. We're going to start by writing out the correctly balanced equation, and this is the thermochemical equation for the delta H you were given. You could have written it out this way, but notice if you do this without the fraction, now you have to double the delta H. Either one will work. You'll get the same answer, provided you change the delta H appropriately. We're going to use the first equation, and then we'll identify the if and then. The 8 grams of oxygen is the if statement. The delta H is the then. We're going to convert our oxygen from grams to moles. So we do out that equation. Grams divided by molecular weight equals moles. So we have 0.250 moles of oxygen. We're looking for the value for delta H. We're going to set up our ratios. Minus 242 kilojoules per mole of reaction is to a half mole of O2, as X is to a quarter mole. Now we're going to solve the sucker, so we're going to cross multiply and divide. And when we do that, we get minus 121 kilojoules. So to review, 5 types of chemical reactions. Synthesis, many things become one product. Decomposition, one reactant becomes many products. Single replacement, one element knocks out and replaces another in an ionic compound. Double replacement, 2 ionic compounds switch ions with each other. And then combustion, where a hydrocarbon or a carbohydrate reacts with oxygen and you end up with carbon dioxide and water. Double replacement reactions must produce a solid, a liquid, or a gas, or any combination of the three. We have one variation that we covered, thermochemical reactions. That takes into account the heat exchange of the process, or the enthalpy. The equations can have fractions in it, and the reaction can be endothermic. Heat flows into the system, and that means the delta H will be positive, or exothermic. The heat flows out of the system, or the delta H will be negative. Delta H is a stoichiometric quantity. That makes it an extensive chemical property. It depends upon how much you have. There are 2 subtypes, acid-base reactions, which are a subtype of double replacement reactions, and reduction-oxidation or redox reactions, which are subtypes of more than one type of reaction. And we're going to cover acid-base and redox in separate videos. So that's the introduction to reaction types. We're going to continue with videos on acid-base reactions and redox reactions.